This little chat is going to be about things I've done over the last umpteen years. There's a ton of slides. I'm not going to dwell too long on each one, or we would be here all night. So I'll kick the thing off. And my microwave life started with one of these things, which is one of them, a little Philips gunplexer module, which operates on, they were made for 10.525 gigs, but there's a tuning screw on top. And I think I've got a little laser pointer here. There we go. I can move a little dot around. So that's the tuning screw up there. That little thing, you can screw that in or out, change the frequency where you want. And we had a pair of these things operating on around about 10, well, mine was on 10.4 gigs. That is the gun device on that side and diode detector on that side there. Very simple thing. You just feed it volts and 10 gigs comes out the front. So not too complicated. Now, that's a little graph showing the characteristics of what most people refer to as a gun diode, but they're not actually diodes because there's no PN junction inside the thing. It's just N-type material, period. 3 layers, and they've got different doping levels on the different layers. And it has this little negative resistance region on the curve where when the voltage goes up, the current goes down. And when you're operating in that area there, it generates RF power on about 10 gigs. And as the specs say, you get about 10 milliwatts out. And the frequency pushing, you normally operate them on around 7 volts, but the frequency will vary 4 megahertz per volt. So that's how you modulate the thing. You just put some audio onto the supply rail and it generates wideband FM. Also note temperature coefficient, 150 kilohertz average per degree C. So they're a bit drifty. Anyway, that was the basic arrangement. We've got 2 units. One of them's on 10,300 megs. The other one's on 10,400 megs. And a little bit of the RF coming out the transmit side feeds back into the detector and acts as local oscillator. So it mixes with the signal coming from the other end and gives you an IF. And in our case, it was nominally around about 100 megs, and we used FM radios. The modulating side was just a little audio amplifier feeding not very many millivolts of audio onto the supply line to modulate it. So quite simple, but there was that's my logbook, first contact, the one in red. I didn't bother to write down for some reason how far we worked. Can't remember, but successful contact. I then decided to improve things a bit. I got an old car radio, as you can see in the lower left. That's the top of the car radio down there, and there's a box stuck on top. Some electronics in. I tapped out the AFC voltage from the detector in the car radio and used that to compensate for the drift in the gun system. So if it started to move and the AFC drifted off to the side, that would alter the voltage to the gun device and drag it back on the frequency. And basically, it would stay locked to the other end for, we tried it for 24 hours and it never moved at all. So very, very stable system. That's the little box with the gun module in it. I had a preamp on 100 megs using a MOSFET of some variety. I don't remember what now. That's what the box looked like. You can see with that little red dot, this is a screw which I tapped into the top of the little horn on the front. And that let me adjust how much of the RF coming out fed back into the receive side to optimize the mixing arrangement. And that was the module sitting in the focal point of the dish. PIN 5ZT had 2 of those dishes, and they were made for audio, like eavesdropping on people and stuff with a microphone or whatever in the focal point and pointed at them. They were made out of fiberglass. The surface accuracy was appalling to say the least, but they did provide some going on 10 gigs, so it was quite useful. We reckon the dish gain was probably about 20 dB, and for a dish that was around half a meter diameter, that is rubbish, really, but it is what it is. Better than nothing. Anyway, we tried a contact from Mount Lofty up to the hummocks, which was, I did write it down there somewhere what the distance was, about 120 kilometers. And this was in 1988. And at the time we did it, that was actually a VK5 record. Although at the time we did it, we weren't sure about that. But anyway, there was the results of 3 tests there. Tim managed to source some microwave preamplifiers from where he was working, and they provided significant gain at 10 gigs. So I arranged a little system with adapting the front of these things to a bit of waveguide so I could put the amplifier in line. And we got 3 tests there. Number 1, I had the dish and the amplifier. Tim had just the dish. Test number 2, I was using the dish and amplifier. Tim had just a module, no dish, no nothing, just that. Cool. And I could hear him okay. He heard nothing from me. Then the 3rd test was both of us just using a dish, but without any RF preamps, and we had 5.9 signals both directions, noise-free. So given the simplicity of the device, it worked very well. Anyway, that was in 1988. Shortly after that, boom, I took a break from anything radio related for about 16 years. It was like work, family, other things like that sort of get in your way of your life. So anyway, after that, 2006, I moved to a new house, which necessitated moving boxes of gear I'd had in storage, and thought this might be a good time to return to AR. And they dropped the Morse code requirement for the full call, the 2004. So I thought, well, I can work HF now, all the bands. Happy days. So I went and bought an IC7400, put up some HF antennas, and got on the air HF. About 3 weeks later, after putting up with static crashes, parallel noise, interference, and everything else that makes HF a pain in the ass, I went back to VHF again. So anyway, around the same time, I became aware of the VHF UHF field day contests. And I thought, well, microwaves will give us a better score. So I dragged out the old gun system, and it was still working. So duly entered one of the contests, the Spring 2008 contest, as part of the 5L board. The actual transverter, you can't really see, it's in that brass surrounded bit underneath that aluminium plate. But we used that for 1296. Okay. The gun system for 10 gigs. Tim was a roving station. We activated 4 squares, and we got third place in the multi-op 24-hour and second place in the multi-op 8-hour. So I thought, oh, well, this is looking promising. So we made a plan. Encouraged by the third place result, how do we win? Now, the Geelong Club had won the multi-op 24-hour section in 29 out of the previous 33 contests that had existed. So time for a change. Can't let the BK3s have all the fun, so the plan was hatched. We needed to have all bands from 50 megs to 10 gigs without spending a fortune. Needed to activate as many grid squares as possible. Long distance contacts not required, just a lot of driving. And the equipment had to be portable, ideally operating from the car without unpacking anything. So for 1296, I used the same mini kits transverter that I'd used in the previous contest. 2.4 and 5.7 gigs used audio video senders designed to send your TV picture from one room to another. You could get them for 2.4, get them for 5.7. And we just fed audio in the video socket. They were FM modulated, and it worked. So I normally they come as 2 separate modules. One's the transmitter, one's the receiver. So I just put the 2 in the one box, and with a transmit receive switch, fabricated a horn out of some copper and aluminium. And since copper and aluminium don't solder together, I just used a bit of duct tape to snap them together down like that. It worked. And that was the 2.4 gig arrangement hanging off the back of that grid pack antenna. So 3.4, the odd one out, that was built from a mini-kit's 1.2 gig FM ATV transmitter. Again, just feeding the audio in where the video would normally go, so we don't end up with 18 megs of bandwidth, just 100 odd kilohertz. A mini-kit's multiplier, a C-band satellite LMBF for the receiver, down converter, transmit antenna with an old spray paint can, and a few other bits and pieces. And for transmitting, the ATV transmitter was set to 1170 megs. It's got a little PL thing on it, so you could program what frequency you wanted. That went into a ×3, came out on 3510, which we can't use anymore, but we could at the time. On receive, the LMBF local oscillator is 5150, so it's an upside down conversion. So 5150, that's the 3510, gives a 1640 IF. That mixed with 1200 megs coming out of the ATV transmitter with no modulation, just became a local oscillator, mixed it down to 440. And that just ran into a Uniden scanning receiver. So that's what the 3.4 gig looked like. We've got, there's the C-band LMBF. We've got the 1296 FM ATV unit there. That's the tripler. There's my old spray paint can with the feed going in the side and a couple of tuning screws to make it work a bit better. Audio went in there through a little amplifier and off to the ATV thing. And there was a antenna changeover relay there to select where the RF from the ATV module went, depending on whether we're transmitting or receiving. So it kind of worked. And on 10 gigs, Gunplexer. I still had the old system, but I thought, how small can I make it? So I made almost a 10 gig handheld, which is a little aluminium box with the module in it. And down here, there's like one of those little FM radios, the things you'd get that were about, little handheld things. And I took the guts of that out, chucked it in there. So all it needed was external power and a microphone, and it was 10 gig handheld unit. And it worked. So that's how we put it all together in the back of the car. We've got the 4 microphones here, which were for into the 2009 summer field day. Boom. And those are the grids we activated. So as you can see, this involved about 1,300 kilometers of driving over the whole 24 hours. Which one was it? QF06, I think. There's a little place up there called Blue Pot. And we were there in very late night. It was pitch black. You couldn't see anything. There's no street lights. There's no nothing. And there was insects flying around that radiated a very low frequency hum. So I don't know what size they were, but it wasn't like a mosquito. This was like a low rumbling noise. And we thought we were about to get attacked and eaten. But anyway, we survived and scored 13,500 points in the process, which was an all-time high score at the time, and we beat the Victorians by a very healthy margin indeed, and annoyed them no end. They did, well, we did that twice. After the second time we did a similar thing, they said, right, that's it, rover category, boss pig. Anyway, so time for an upgrade. So while wideband FM had served the purpose of winning that contest, you know, it was very short range. It would work line of sight over a couple of kilometers or something like that. Beyond that, it started to get a bit iffy. So my plan was to have 1, 2, 1.2, 2.3, 2.4, 3.4, 5.7, and 10 gigs all in one box. But ran out of space. So I had to settle for 1.2, 2.4, 3.4, 5.7. 10 would be separate. 2.3 could wait till later, much later as it turned out. A couple of months ago, in fact, was when I actually have a 2.3 gig device. And design and construction commenced in July of 2009. And 4-in-1 box would comprise a 10 megahertz isotemp OCXO as a reference. There's a chap called Steve Hicks in 5AC was logging off. I think he still sells them, don't know. These things called Apollo 32 boards. Shut that up. And that's a PLL device, which had a binary input which you could use to pick from a list of preset frequencies that were built into the thing. And because he hadn't sold many of them to Australia and their allocations are a bit different to ours, he was quite happy to add some extra frequencies for me. You know, I said, I'd like this. I'd like the option of a 144 or 145 IF on the various things. So he said, fine, you know, I've got heaps of spares, so we put them all in. So 1.2 gigs is the mini kits transverter, 1 watt amplifier, 2.4, another mini kits transverter, 2 watt amplifier, 3.4, a W1 GHZ transverter, and 2 watt mini kits PA, 5.7, another W1 GHZ transverter, and a 1 watt mini kits PA mini kit sequencer, plus all the control electronics, which I built, and it ended up in a box looking like that. With a rotary switch on the front where I just selected what band I wanted, and connections on the back for antennas and the IF radio. Inside, it looked a bit like that. You can see the rotary switch has got the 2.3 and the 10 gigs written on it, which never happened. On the left, I built a little charge pump thing to generate 24 volts to operate the relays, because they're all 24-volt relays. In the middle there, where was my pointer gone? There we are. This gadget here, that's one of those TV antenna splitters. So that took the output from the Apollo 32 LO board, which is generating around about 1 to 1.2 gigs output. And that just used that as a splitter to divide it up and send it where it needed to go. And that worked fine. I added some ERA5 mimics inside to boost a couple of the outputs up a bit. Looking down on the top, you can see that's the doubles the LO for the 2.4 gig transmitter, which is there. That's the 2.4 gig amplifier. There's the 10 meg reference oscillator. That's the Apollo 32 LO board there. And that's a big diode matrix controlled by the rotary switch to select what frequency you want that board on, and to control all these relays over here, which switch DC to whichever transmitter you want on at the time. Next slide, that's looking at the back. So there's the 3.4 gig amplifier, the 5.7 gig amplifier, antenna changeover relays down here for 3 and 5 gigs, the 5.7 gig transverter, and that's the transmit receive sequencer, which is where the IF radio connects to, basically. Another view down on the top. There's the 3.4 gig transverter, 1 watt PA for 1.2 gigs, and the 1.2 gig transverter. And there's the LO board, another sort of view of it. If you want to have a look, the actual box is over there. You can have a look afterwards. But now then, clean up in R2400. I've got a spectrum analyzer. I thought, I can look at the output of these things, and they look pretty good till I looked at the 2.4 gig one. And what came out of that transverter was that. 2 big spikes at plus or minus 144 megs, and there was more big spikes every 144 going up and down, you know. So it's like, okay, I need to clean that up a bit. So I found an old 1, 2, 3, 5 hole cavity filter that I could tune to 2.4. So I stuck that in series, and the result was that single spike down the bottom, everything else gone. So happy days there. That sorted that out. The 5.7 gig, because I made the PCB myself on that Rogers stuff that's got the consistency of chewing gum, printed circuit board, the brown very soft. I don't think I made it quite accurately enough, and the performance was woeful, to say the least. So on the transmit output, I had to add, there's a little amplifier in that thing there up the top. That's that bit. And you probably can't see it, but there was an eBay type LNA that I picked up that worked on 5.7 and stuck that in front of the receive chain, and that picks things up. 10 gigs. I went and sent Mr. Kuhn some money and got his G2 transverter kit, which comes pretty nicely prepared, all the bits and pieces in little boxes and, you know, little holes like that with everything laid out in it all very nicely, you know, and very extensive instructions on how to put the thing together, which I duly did. And that's what it looks like, or the bottom of it, all done up. goes in a box. There's a couple of pipe cap filters on top. Originally, it had a crystal oscillator with a heater on it to try and stabilize it, which didn't work very well at all. Oops, I'll just go back a sec. So I actually got a 10 meg referenced replacement for that. Kuhn made a thing that generates the 106.5 megs, I think it is, that the crystal's on. That's locked to a 10 meg reference. Anyway, more 10 gig wideband FM just for the hell of it, because whilst I built that Kuhn thing, the other people that I was working at the time still were using 10 gigs wideband FM. So I got a satellite LNB and thought, well, this will work. The LO's on 10.7 gigs. So that gives an IF of 400 megs for a 10.3 gigs signal coming in. Good, good. The only thing is they've got this hairpin filter here, which is on 12 gigs or thereabouts. So a sharp knife and a little strip there, just to remove the filter entirely. Let's not have it, you know. Worked. And I put that into a box. Sorry, this is the transmit replacement. No more gun plexer type oscillator. I just took 433 megs from a Yaesu FT60 and put some multipliers in there. So times 24 gives 10.392 megs, and a lot more stable than the gun device. I then changed it a little bit again. You can see I've got two commercial little amplifiers there, which actually work from 10 to 15 gigs. They're sold as they were on eBay as low noise amplifiers. So I put them in, improve things a bit. Same time, I got a 24 gig gunplexer device and made up 24 gig wideband FM as well, just to add to the mix and improve field day scores. So that's what the thing looked like in the end. You look over here, we've got the 24 gig horn at the top. This one here is the 10 gig horn, which is used for transmit only. And that little gadget there was an Avantec amplifier, got off eBay. It's about 200 milliwatts out on 10 gigs. So that was stuck in the line. And that's the LNB receive converter down to the Uniden scanning receiver. So at the box at the bottom, 70 centimeter, that was the FT60 plugged in there. And I can't remember where, somewhere, the microphone for the 24 gigs probably plugged into the back of that as well. So that was 10 and 24 wideband FM, which performed better than the gunplexer system, a lot better, especially with the LNBF. I mean, they've got huge gain, you know, compared with just a plain diode mixer. So. Right, digress, some antennas, yeah. Well, it's combined with the feed. So LNB is a low noise block down converter. That's just the electronics, RF in and out. The F it's got the feed built on it as well. Right, some of the antennas I played with. That little picture on the left is a tri-band feed made by WA3 RMX, and it's designed for 2, 3, and 5 gigs. That was the theory. Performance was marginal at best, but hey, we'll make use of it. In the middle there, we've got a 2.4 gig. I'm trying to think what I'm looking at here now. Oh yeah, that's a 2.4 gig grid pack, and I've got this feed sitting in that dish down there. So I was just comparing the two, I think, at the time, see how they compared on 2.4. But I could also use that for 3 and 5. And I've got another horn there. That would be a 5 gig one sat on top of the box over there. There's another antenna arrangement. So we've got a Yagi on 1.2 sitting about here somewhere. 3.4 gig grid, 3.4 gig horn, which is there, 5.7 gig horn, which is next to it there, and the 10 gig dish. And that's the only photo I had, but I actually made an adapter to go in front of the gunplexer to adapt it to a bit of waveguide with an SMA connector on the end, so I could connect it into up there. Just an old Foxtel dish. I think I've still got it kicking around somewhere, but that was a lot better than the fiberglass exercise. So the Kuhn transfer is moved onto that dish. It's actually underneath that aluminium plate. You can't see the electronics in that photo, but it's underneath this plate here. And I managed to acquire a fairly large dish, 1.2 meter dish with a 5 gig feed, which I've used twice. Don't need it. It's complete overkill, you know. So it just sits in the backyard now. But I did some mechanics so I could put the two dishes one above the other. There's the Kuhn transverter sitting underneath the aluminium plate up here. What else have we got? That's a smaller dish. It's on the same mount. That mounting system had the 1.2 meter dish or the 60 centimeter dish. The dish is just lifted on and off, and it came with feeds to suit both, the large and the small dish. There is the two horns there. The 3.4 is the larger one, 5.7 the smaller. Anyway, and there's two more transverters in there, which I'll talk about in a bit. Those two, that one there and that one there. More antennas, all stuck in the back of the car for a field day exercise. So we've got 1296, 2.4 Yahoos, 3 gigs, 5 gigs, and the 10 and 24 wideband FM arrangement up there. I can't remember which wheels they are used it in, but one of them. So it's just in the back of the station wagon, you just park the car, lift the back up, and away you go. Where I was working was parked somewhere down the same piece of straight road with a grid square boundary in between them. Anyway, another 3.4 gig transmitter using the W1 J6 NCB, which is themselves. Mini bits oscillator on 542 to 666, 156, 144 gigs, 3400 mix. And I think that there was, I think it was 4 watts amplifier and some eBay, might have been 2 watts, can't remember. I'm not even sure where it is at the moment. But anyway, so some electronics, that's the transverter board, changeover relay, and oscillator board. And that's the circuit of the thing. Very, very simple. Receive side, a couple of minutes. Well, sorry, 1 minute in the receiver, and then it goes through pipe cap down to the mixer. And the local oscillator comes in, this doubles it, then amplifies it, goes into the mixer. The transmit side, IF comes in that way through the filter and takes this route out to the transmit connection. And, you know, it's milliwatts of power. They work. And, you know, you can get a long way with a few milliwatts on these frequencies. That's what the underneath of the board looks like. It's exactly the same board. It's designed to work on 2.4 or 3.4 gigs. We have these quarter-wave chokes, and depending on whether you want it on 2 or 3 gigs, you fit the decoupling capacitor either there or there. That one's fitted there, so that's for 2.3 gigs. And that was the only difference between the boards and the tuning of the pipe caps. So they could do either. So just for the hell of it, I built another 3.4 gig transmitter. This one hasn't got any amplifier in it. It's just the bare transverter. Same arrangement, the mini kit's local oscillator, and that's the electronics that interface it to the IF radio, which is an 817. Well, I believe I use the FD817. That other thing in the other picture was an IO wave unit, which I think it came from somewhere in Melbourne. I was spotting it, and myself and one more ad, 2 meter IF, can be compared to 5.7. They're originally designed as a full duplex data link, so they would transmit at the same time on 2 frequencies that are offset by, I can't remember what, a few hundred megahertz. Underneath the PCB, it's a very elaborate filter unit that separated the transmit and receive parts. So that was the input diplexer arrangement. This is the transmit chain out here. That was the PLL for the local oscillator. The receive input, mixer, filtering, remember the whole arrangement now. And over here, this end was control electronics, a microprocessor of some sort, a microcontroller, and that was the DC side of the world generating whatever voltages it needed. So after conversion, got rid of that filter, replaced it with a bit of wire, got rid of that filter, replaced it with 4 little coils tuned to 144 megs. Had no idea what the microcontroller was doing, so disconnected it from the PLL and added this little board which has got a pickaxe microcontroller on it, which I programmed up to work the PLL and work the changeover relay. Changeover relay? Yes. Changeover relay somewhere there. No, that's a DC relay, that one. Antenna changeovers underneath all this lot, you can't see it. And that was it, the horn antenna all set up, ready to go, working. I think with a old Yaesu, something I was using as an IF radio at the time. Anyway, moving on, decided to build another 10 gig transverter, this time using the boards that were being designed and sold by Graham, VK3XDK. And he was selling these as a kit. They're no longer available. He was getting too much grief from people that couldn't make the things work, I think, and he just gave it all away as a bad joke, you know. But he sold boards for the local oscillator multiplier and the actual transmit and receive units going down to the mixers. These are the 2 boards. One's, I remember which is which. One's the oscillator this one's the oscillator multiplier, and this one's the transmit receive. There's no components on them in those photographs. And the whole lot was put into that box. So we've got those 2 boards mounted on their edge on those bits of aluminium plate there. We've got the interface to the IF radio and the sequencer. That is a surplus gadget I had lying around that generates 24 volts from 12 going in, just purely to work the antenna changeover relay, which is hiding about there. That's a 10 meg reference oscillator. This little arrangement here generates the, I'm trying to think, it's around, the LO for mixing is at 9936 megs. It's a 70 centimeter IF. So it was 1/4 of that came out of this little PLL box here. And again, that was a guy on eBay selling them. You just when you ordered it, you said what frequency you wanted it on, and you programmed it for that and sent it to you. Job done. And hiding over here is that little Avantec 200 milliwatt amplifier, which I ratted from the wideband FM signal, which was no longer in use. And I thought, right, 24 gig transverter. Around at the time, there was on eBay from somewhere in Israel, I think, these Thales modules that took all the hard work out of the 24 gig bit. And they generated about 1 or 2 watts, I think, on the transmit side of the bit. So I acquired one of them and a few other bits and pieces, put it together in a box. And because the module's got 2 waveguides, one for transmit, one receive on the back, I thought quick and easiest, I did some old bits of sheet copper, which came out of an old hot water service, cut them up, made 2 horn antennas, soldered flanges on them, bolted them onto the back. And that's what I used initially. That's a quick view of the innards with the Thales module there and various other bits of electronics and things like that kicking around. I eventually added some coax to waveguide adapt on the ports here, going to a changeover relay, and then added a bit of waveguide, and there's a penny feed on the end of that. That's a homemade dish as well. I had an actual dish, and I used that to make a plaster mold. Then I went down to Bunnings and bought one of their fiberglass kits, and I made some of those dishes from the mold. It seemed to work. They're probably not super duper accurate, that's all. Anyway, so what else have we got? Oh, right, yes. These Thales modules were designed to work on 23 gigs. So you want the local oscillator had to be on the high side. So the local oscillator going into the thing was actually on 25.33 gigs. And that gave a first IF of 1282 megs. Then the second local oscillator, 1426. So that's high side as well. Came out as a 2 meter IF. So because both the local oscillators on the high side, the tuning on the radio works in the right direction. You tune up, it goes up. And tucked in the back, which is a bit hard to see, somewhere in here, there's a homebrew 1282 megahertz interdigital filter I put in there just to clean up that bit of the frequencies to make sure there's no little birdies or blips or anything like that floating around. And just to be different, another 1296 transverter. This particular one used more mini-kit stuff again. So there's a mini-kit sequencer, mini-kit 1296 transverter. That's a ZL PLL local oscillator. And the amplifier over here is one of Alan VK3 XPD's devices that he acquired, modified to make work on 1296. And I won that at one of the Gibbs Tech conferences. I think it was a door prize or something like that. They called me out and said, "Hey, you've got this." I thought, all right, I'll have to do something with it. So I built another 1296 transverter. Anyway, 4 antennas. As you can see, there's a couple of grid packs there. So one's 3.4, one's 2.4. There's another picture of that coming up. Those are 2 horn antennas you've seen in previous pictures pointing at the window of my car. Because we thought, let's go and see if we can set a record mobile. I mean, to get a mobile record, you don't actually have to be driving. According to the rules for doing records, provided it can be used while driving. I mean, Doppler shifts to be horrendous on those frequencies. But I was parked at one end, and we managed 144.9 kilometers on 5 gigs, and 165.4 kilometers on 10 gigs. So, and that's just with those little antennas. That would have been a thing from 0, so 100 megawatts of RF antennas. I can't remember what I was using on 5.7. And that was in 2011, so really while ago. That's another shot of the grid pack antennas on a winter field day. You can tell by the plastic bag trying to keep the electronics dry. That was wet, driving rain, horrible day that was. I made up, you can't really see it there, but there's a homebrew feed to make that work on 3.4 gigs. And 1296 Yagi sitting up there. That's a closer shot of the 1296 Yagi. That was a construction method that was described in the AR magazine at one point years back, just using aluminium welding rods. You drilled a hole through, pushed the rod through to the right point, and then just whacked the top of that T-section aluminium with a hammer and a chisel to jam it in there, and there you go. Elements stuck in place. Anyway, I'm still using that. Works fine. I decided to try a loop here. And it designed for one on 1296, and I just scaled it exactly, in proportion 1296 to 3.4. And it works surprisingly well. The one just above it is a 2.4 gig Yagi I made up. That's a close-up of the feed arrangement on the loop Yagi. You can see the coax, the semi-rigid coming up through the middle and connecting to the top of that loop there. There's those 2 horns you've seen before, 5 gig on the right, 3.4 gig on the left. The 5 gig one was made out of tin plate, a cut up tin can of some sort. The one on the left is made up of sheet aluminium, and the waveguide sections that they're mounted on are both homemade, just from folding up bits of copper or brass. I can't remember which. And for the 3.4 gig one, obviously you can't solder like you can for the 5.7. I could solder the tin plate to the copper. Can't do that for 3.4, so I just use nylon nuts and screws to bolt it in. And because they're nylon, they have little or no effect on the RF. It works. I experimented with a 90 centimeter dish. So I made a plastic pipe, PVC pipe sticking out the front. The one on the bottom right is a 1296 Yagi feed. One on the lower left is a 2.4 gig feed in a can. Upper right, 3.4 gig feed in a can. And they all worked. They all worked fine. I no longer have those, I don't think. I used the dish for something else and ended up getting cut up. So. That's a 60 centimeter dish with that WA3 RMX tri-band feed stuck in the middle of it. I'm still using that for 2.4, nothing else. There's somewhere field thing, I'm guessing. So we've got the 24 gig on the left. I've now gone to panel antennas for 3 gigs and 5 gigs. I'm pretty sure that's the 3 gig one with that thing stuck on the front. That's the 5 gig one. And we've got the 1296 meg Yagi there and a little commercial 2.4 gig Yagi up there, which came off eBay for about $12, I think, delivered from China. I think, how the hell did they do it? You know, but it worked. I know some people have bought them and they've not been so good. So. Right, that's those grid arrangements again. So we've got 1296 Yagi here, 2.4 gig that side, 3.4 gig that side, 5.7 down here, and 10 gigs up on the top. And you might notice that I'll show you pictures of this in a minute, but all the electronics have been now moved to a thing behind the dish instead of on that plate that was here. So the Kuhn unit, I got that PLL stabilized crystal oscillator to replace the 106.5 meg crystal, which tended to wander despite the heater and everything like it. I got a low noise preamp. I mounted the preamp right up next to the feed arrangement at the top, and the transmit signal came up that bit of coax up there. And I also found this surplus Hindi power amplifier, which outputs about 2 watts in the range. And that's what the whole lot looked like. So the electronics is inside this bit at the back, feed up there, and I put metering and things on it so I can see what's going on and just confirm that, you know, things are actually working. Now, you remember the second 10 gig transverter using the EK3XPK kit. I decided to rearrange that. So I got a 10 gigahertz panel antenna and built a box around it. So the panel antenna becomes the front of the box, and I built the rest of it, and I moved all that lot inside that box. So now it's you know, a lot more portable. I don't have to worry about what antenna I'm going to use on the thing. It's just there, whack it on the tripod, and away she goes. I've got a little plate on the bottom that clips onto that tripod. So it's just like a quick release on the tripod, on and off, if you want to swap it. Now, the 4-in-1, I thought I need to improve this a little. So I got rid of the rotary knob for switching, and I added buttons here. So there's one button that just cycles through the 4 bands, and this button here cycles through the 2 possible IF frequencies, 144, 145. And I also added a remote head that can sit on the end of the table. So, you know, the main unit can be outside where the antennas are, and the remote head can be elsewhere where I'm actually sitting and working. You know, I can work from there. Now then, not having enough 3.4 gig transverters, I decided to build another one. And this one's in a Bunnings toolbox. So again, it's the W1 PHZ transverter, an LO from ZL-PLL from Wayne ZL2 BKC made these things. He's now Silent Key. And a stealth microwave amplifier, eBay, you think. About 25 watts out. And it's all built in the toolbox with a power supply. That actually runs off 240 volts. Not, I mean, I could make it up 12, but I put a power supply in there, and, you know, one of those kettle cord sockets on the back to plug it in. Only ever use it at home. Anyway, what else along the way? These are just a selection of pictures of various things I've messed about with various times. Bits and pieces for another 2.4 gig transverter, which I've acquired, not done anything with yet. I acquired these a long time ago. I'm trying to think what that amplifier board down the bottom, I think it's capable of lots of watts on 2.4. There's XRF 286 MOSFETs on there, a pair of them. So I've forgotten what power it will deliver, but significant. But experience has shown you don't need it, you know, unless you're going to bounce signals off the moon or something like that. I made up a signal source using a Yig oscillator, like this one on the right here. That's another Yig oscillator. I can't remember where that came from. Surplus item from someplace. but this was a little project I decided to do. It only works in whole megahertz, but you just key in the frequency you want. You press the hash key, and that's it. So if I want a test signal on 103.67, punch that in, and out it comes. Now, another handy thing when you work with microwaves is something to indicate that things are actually working. So, diode detector. The one on the left, that's, now I've got the call sign of the guy that makes them, but they're little log periodic antennas that are designed to work about 2 gigs up to 11 gigs or something like that. They're absolutely rubbish at 10 gigs, I can tell you that. They don't work at all. But in the box underneath, that's just a meter and a little pot, so you can turn it up, turn the gain, well, attenuate the signal to DC going in. Middle picture is a horn with a 24 gig unplexer module on the bottom, and I'm only using the diode detector just as a simple detector of 24 gig RF. And on the right, the gadget with the horn bolted on the front is a Hewlett-Packard device with a diode detector where the bit of coax is plugged in. And there's a tunable slide. So the knob on the end here, you can turn that, and that moves the backstop in and out of the waveguide, so you can tune the system to whatever frequency you're working on. So it covers quite a wide range, but I'm only interested in 103.68. Now then, as part of the testing exercise, I built this little box, which one will allow me to switch between the different microwave bands and the different transverters I've got and feed it all into one FT817 radio. So on the display here, it will show what frequency you're actually on. And if you sit there and twiddle the tuning knob on the radio, that number will change to reflect where you're operating. It tells you the mode, USB. On the back, we've got, as well as a power plug, that connector there goes to the 4 transverters in one box. So it emulates my remote control for that thing. So if I press the button for 3.4, it'll put that box on 3.4 gigs. Over here is where the FT817's cat control plugs in. Now, as far as the PC that you're plugging into is concerned, this box appears as a radio with its own cat interface. So it will talk to the PC. RF from the 817 goes there, and there's 6 outputs. So depending on what button you press, the 817 is connected to one of the 6, and they go off to whatever transverters you've got. And it makes life very easy. The interfaces with VKCL, at the time, I got Mike, the author, to modify VKCL for me because it had a limit of 2 gigs, was its upper frequency limit. It wouldn't work above there because they're using binary numbers to pass the frequency backs and forwards in hertz. So for a 32-bit number, the upper limit was 2 million, I've forgotten the number now anyway, someone can work it out. So we did some mods, so it punches it a bit and got it all to work. I needed to check my 10 megs, so I decided to go and build a 10 meg GPS systems signal source, and that was all my own homebrew design, based around a pickaxe chip controlling an ISO temp OCXO, and I still use that in the shack now. It just sits there and gives me a nice stable 10 megs. Probably not the best way of doing it, but it works, so I don't care. Other 10 meg sources, that's another one I've got kicking around. The one on the left I bought just to try out, and it works quite stable. I think it's about $20 or $30 off eBay. The one on the right, the upper picture is what it looks like in the box. The lower picture is the actual oscillator in its can, just a 10 meg device. Turn it on, and they take about 20 minutes. Those larger ones take about 20 minutes to get on frequency, but once they're going, they're very stable. I never use GPS in the field. I just use these 10 meg oscillators. They're cleaner, and they don't move that much. If I want to check them, every 2 or 3 months, I'll compare it with my GPS referenced one and give them a little twiddle, but they generally stay pretty close to where they want to be. That was another project in a Mitsubishi van, which I no longer own, but I had, as you can see, 24 gigs. So there's 24, there's 10, there's 5 and 3 there, and there's Yagis further up that thing for 2.4 and 1.2. And there's actually a rotator down the bottom. So I could sit inside the van, and I put a desk inside it by the back seat, so you could sit there with my pick what band I want to work and do everything, and turn the rotator and just contest from inside that thing. The only awkward bit is if someone was, towards the front of the van, you'd have to move the van because you can only turn the dish so far. Other projects, mods for the FT817 mic to build a beacon into it, just generates an audio tone. So using the little switch that's on the back, which is like the tone switch, which complete waste of space. This thing, if you switch the tone on, it transmits my call sign every 30 seconds, and the rest of the time it's just a steady tone going out. So very handy when you're lining up microwave stuff and you want a signal on air. You can just flick the switch, beacon on with a more side end, and it also generates a little Roger beep when you're talking. Every time you let go, it's a little beep. Because sometimes if it's a really weak signal, it's hard to tell when the other station's finished. So having that little beep certainly helps. What else we got? That was a 10 gig beacon project. I started at one point, built it all up. It worked, but never actually. I wanted to do some propagation tests across the Gulf, and the idea being was I was going to install this thing somewhere around Port Vincent, and so I could, monitor the signal on this side of the Gulf. But I could never find anywhere where I could leave it safely, where someone wasn't going to bugger about with it. So nothing ever happened. That was a field day setup. I made up that little box. So I got my FP897 in the bottom, two 817s. One of the 817s was connected to the 4-band transverter box. The other 817, I had a little toggle switch here. I could flick it between 10 gigs and 24 gigs. So just a case of remembering to pick up the right microphone when you go to talk. Made that mistake a lot. So there's some more field day shots with antenna setup. This was on top of where the wind farm is, up above Lockheed. We arranged with the landowners and the wind turbine people to get access to that lot. So it's a bit of a rough trek, but we went up there. And as you can see, it's a bit squeezy in the back of the Mitsubishi when you get everything whacked in there. What else? Something different. A 24 gig transverter from, you guessed it, Mr. Coon. This is just a diode harmonic mixer. So you've got almost 12 gigs coming in there, 11 point something. And this doubles it, mixes it with the 2 meter IF, and you have 24048 coming out there at the microwatt level. Not very much at all. Another little gadget picked up at Friedrichshafen. There's a bunch of Italian guys there selling these things for not a whole lot of money. I can't remember how much they were now, 20 or 30 euros, something like that. But they're 12 gig phase lock loops with a little 10 meg reference can on the back. You just needed a microcontroller adding to these pins here, and you could program it to whatever you want within the range. You had to do this little loop here was control the tuning. You had to add some solder on a little, modify its size very carefully to get it to work where you wanted it to. But I've got one that works with that Flea Power 24 gig, acts as the local oscillator for that on 11.9, whatever it is. And I've got a second one that's on exactly half of 24048.1. So I can just feed into a diode, double, and be a simple 24 gig, well, I say beacon, just a carrier. ADF 4351 PLLs, a lot of them around on eBay from various Chinese sellers. That's that variety there. And I've added a little Arduino controller, and that was my homemade voltage conversion because the Arduino, I think, was 5 volts and all this lot wanted 3. So I had to make voltage changes. These Chinese ones, the quality of the output was a bit rubbish. There's exactly the same chip on a board from a Greek chap, SV1AFN, who makes these things, and he makes them a hell of a lot better than the Chinese people do. He's got all the required decoupling and things like that on supply lines going into the chip, whereas the Chinese boards, they just join the 3 supply lines together and that's it. Noise gets everywhere. But they work and, generate RF up to 4.4 gigs, I think. That was one of the Stelix YIG oscillators, same as I put in that box. It was my signal generator. This was a board I added because inside these things, there is a 10 meg reference, but it's not super stable. So this is some electronics I added to phase lock the internal 10 megs with an external 10 meg going in, which works fine. It's just a exclusive OR gate in that thing there. Acts as the comparator. Works. The output of these things is not super duper clean. Another project, boards from W1GHZ. That's a local oscillator multiplier and transverter board for 5.7 gigs, and same oscillator multiplier and transverter board for 10 gigs. And that's on my to-do list to actually assemble. I've had them sitting around for a few years now, but I've finally decided to pull the digit out and put them together. Another transverter for 10 gigs. This one, transverter number 3, uses a module, this thing down here, by a company, I'm not sure how you pronounce it, IOGAL or some Israeli company anyway, designed for 10.4 to 11.7 gigs, but they work at 10.368, close to the bottom end. So on the receive side, the module has got a mixer local oscillator input, conventional down conversion arrangement. So I use an LO of 9936 to give a 432 meg IF, and I've got a conversion gain of around 22 dB and a noise figure of around 3 dB, so it's not bad. On the transmit side of the world, they're just an amplifier. There's no mixer to up convert, so you've got to feed 10 gigs in, get 10 gigs out. They generate an output of plus 32 dBm, so shade over 1.5 watts out, and the transmit chain has a gain of 53 dB. So you only need like 10 microwatts of drive going in to get full output, which is not too difficult. So that's what the innards of the box looks like. There's a power control up here. Trying to think what's what. That's a ZLPLL for the local oscillator. That little can over the side there is a multiplier up to 9936. there's a relay here which switches the 9936 between this bit here, which is the transmit mixer, or the LO input there, which is, excuse me, for the receiver on that thing. So that switches that LO output. That was just a diode mixer with an amplifier mimic stuck on it. Output of that goes through a little filter here to the TX input. And the 10 gigs in and out goes through that relay there to antenna connector down here. The stuff in the middle is some DC control for the power supply. Antennas, these are the antennas I've got at home. You can see that stack on the left, on the right, sorry, is what's up on my shed roof. So 2.4 gig at the bottom, Yagi for 1296. The next one up, this one here is 5.7 gig grid pack. This one's the 3.4 gig, and that's the feed arrangement, just a little loop with a plate behind it. That's the feed I made for the 3.4 gigs to replace the 2.4 one that was there. And that's the dish for 10 gigs at the top, the actual 10 gig transverters in that fiberglass box there. So there's some closer pictures of the 5.7, 3.4, 1296 Yagi, and 2.4. That's that tri-band feed that you saw in the earlier pictures. And because the birds like to sit on there and crap all over it, I glued an old Coke bottom half of a Coke bottle over it just to try and protect it from the wildlife. 10 gig transverter number 2, the one that you can see that was built into behind the panel. I added a low noise amplifier, which is a modified LNB. There was a French guy, I can't remember his call sign off the top of my head, came up with a design. These were printed circuit boards, all the electronics on it, designed as satellite LNBs. And you just cut out one particular bit of it, added a chip to generate some negative bias for the FET, and put it in there. And I got it tested. I took it to the UK on one of my trips, and I was at the Finningley round table, and they had a guy there doing noise figure tests and things like that. So I thought, yeah, I'll test this thing. And it turned out the noise figure was 2.6 dB. So I thought, yeah, that'll do. The other thing I added was this little PA, which also came from Friedrichshafen at some point, and gives me 1.2 watts out for the 100 milliwatts going in. So that improves that thing. Onward and upward, 47 gigs. That's this thing over there. This is a harmonic mixer. So there's a chap called Armando, I3OPW, makes these modules, specifically this one here and this one here. So this starts life as an Elcom synthesizer, which generates 11.6 gigs. These came off eBay again years back, out of Israel. There were different varieties of them that covered different frequency ranges. There's a little pickaxe chip on the back there to program it to the required frequency. That 11.6 comes out to this thing underneath here, which is a bit hard to see because it's underneath that other bit, but that's a doubler, which doubles to 23.32 gigs. Dave 5KK gave it to me from his box of bits he had kicking around. I don't know where he got it from. Anyway, the output of that goes to this amplifier here, which outputs about 90 milliwatts on 23 gigs. And that 90 milliwatts goes into one very small diode inside this thing here. So it hammers that diode, the diode doubles it. There's a 2 meter IF goes in there to mix with it, and you get 47,088 is the output frequency, and it's a couple of hundred microwatts. So there's not much there, but I worked 50 Ks with the device, so can't complain too much about it. That's what the inside of the modules look like. So that's the 23 gig amplifier, and that's the harmonic mixer module. And sitting in the middle, right where the red dot is, will be the mixer diode. They're not very big, and yet they survive. 76 gigs and 122 gigs. So this is done in similar fashion. There's a harmonic mixer involved. Got one of Mr. Kuhn's local oscillator modules, which cover 8 to 13 gigs. Surplus item CMA 3824000AUP. They're little tripler modules. You feed the 13 gigs in, and there's a waveguide output on 3 times that, about 39 gigs, and they'll generate, I think, somewhere between 50 and 100 milliwatts at that frequency, and that you use to blast the diode. So 76 gigs, you have 12.648 gigs is times 3 to 37944, which is doubled to 75888. Add on 2 meters, 44 IF, and you get 76032. And for 122 gigs, 13567.33 megs times 3 gives you 40702. That's times 3 by diode. It gives you 122106. Add 144 gives you 122250. And that's what the little CMA tripler modules look like. That's a little aluminium housing for the printed circuit board. You can see how long ago a photo. There's a 2-cent coin there. I don't know when they stopped, but so yeah, so that sits in there. That little hole there is the waveguide output. And then these little blocks here hold the board down and go over the end, and they've also got tuning screws, so you can screw them up and down and adjust everything for the best match. The only thing to be careful of is not screwing that one down too far, because you'll crush the diode. It's right underneath it. Anyway, just to give you an indication of size of these things, if you look at, this is a ruler in millimeters, right? There's the diode. The diode sits in that gap there, right? Between the end of that track and that earth over here. That's it magnified with the diode on it. So those diodes are literally 0.5 millimeter long. And where are we? Dimension, whatever the top one is. The width of the diode, A, millimeters, 0.33 wide and 0.66 long. They're not very big. You don't solder them. They're stuck on with silver epoxy. You pick them up with a wet toothpick. You wet a toothpick and then touch the diode and lift it up and put it where you want it to go. I didn't do that. Dave did the mounting of those things. You've got to steady your hand. And apparently the Austrians recommend a shot of schnapps before you start, just to keep everything calm. Anyway, I decided to put 76 and 122 in one box, which is this big crammed up mess here. So there is the 122 gig bit is on that side, and the 76 gig bit is that side. The 122 feed pokes out here, the 76 gig pokes out the other end. So we'd literally take the box off one end pointed into the dish, and I would just lift the box up, turn it around, and put it back down the other way up again, which worked. I had that at Finningley. Apparently, I won the UK microwave constructors thing with that. I never found out till like a year or two later. They never told me. Anyway, I needed more power. These harmonic mixers are all well and good, but it's all microwatt, and the received noise figures are pretty crappy. So I haven't spent some money in Mr. Kuhn's direction, as it turned out. So for 47 gigs, I bought a MKU 47G2 transverter. They come with a calibration chart with them. Mine had a 6 dB noise figure and 45 milliwatts on the transmit output. So that gives me a 20 dB improvement over the harmonic mixer system. LCOM synthesizer for the local oscillator, which I could switch between two frequencies, so I could have either 144 or 145 for the IF. And that's what the LCOM looks like inside. And I added a little microcontroller there connected to the PLL chip to program it for what I needed it to do. The 47 gig transverter unit has two separate waveguide ports for transmit and receive. Fortunately, these two chaps, Hans and Rudy, designed and manufactured a waveguide switch and control electronics to suit the Kuhn transverter. So it was everything else you needed to go with it, basically. So that's what it looks like inside. That's the waveguide switch there. That's bolted down over, can't remember which is the transmit port now, but that's the receive port that side, which the waveguide switch screws straight onto, and there's a little loop I had to make up to go to the transmit port. But it's designed so that if you had one of Mr. Kuhn's 1 watt 47 gig amplifiers, a vastly expensive item, you could mount it across the top here with 2 bits of waveguide going straight down, but I didn't bother with that. That's the output from the switch, and there's all that's the viewed from the other end with the LCOM synthesizer sitting on top there, and the whole lot went in a box like that. So that was designed to sit in the back of a dish with a feed going out to a splash plate like that there. So there's the waveguide feed going out and splash plate, oomph, and there's my 10 gig transmitter in the box down there as well, just sitting on the edge. That's on top of a mountain called Santis on the eastern side of Switzerland, not far from Liechtenstein. We took all the gear up there, and can't remember how many contacts we made, but we did work some people. Anyway, I wanted all the transverters to use one antenna. No point having separate antennas for everything. So I borrowed an idea from Dave, which is to put each transverter plus its feed horn in a common size die-cast box, which can sit in a cradle behind a dish. So I did 47 gigs first. That's the 47 gig transverter with waveguide switch attached. Put it all in this die-cast box with the LCOM unit on top, whacked it all together. And there's the feed horn poking through there. There's a little splash plate there, and it just sits on that cradle behind the dish. So you can just lift that in or out. 76 gigs, another transverter from Mr. Kuhn, even more expensive. 6 dB noise figure and 1/4 of a watt output on 76 gigs. That's a fair bit of power. And another Kuhn local oscillator, which is that device there. And another waveguide switch from the Austrian guys, sits on there. And with the waveguide switch, you also get this PCB, which has got all the necessary control electronics and everything you need to make it a complete switching transverter. So all good. I thought, bugger it, I'll splash out. And I bought Mr. Coon's 24 gig unit, which is fairly impressive in the specs department. 3.5 dB noise figure and about 2 watts out. So it works very well. Now, they don't have a 122 gig thing from Coon, fortunately. So I took the one I had and put it in the same size die-cast box again. So we've got the little module with the diode in it. There's the little tripler. There's a waveguide output, which is a bit of copper pipe. All the electronics to work the thing. And put that in a fourth die-cast box. And there's a spike on 122.25 gigs. I've got no idea. I mean, the absolute levels are meaningless on that, but that just proves that I've got RF coming out on the right frequency. So I had 4 boxes. 24, 47, 76, 122. I still have those 4 boxes. They all sit in a couple of JCAR cases with the FT817 and some lithium-ion batteries. And that box there is a 10 meg, another OCXO 10 meg reference. And because these are 3S batteries, they only sit at about 11 volts. So to make sure I've got 12, I've got this little boost converter in that box there, which will give me 13.8 volts. That's the dish with the cradle on the back that the units sit in. That little plate on top is for the FT817 to sit on. And that's just a sunshade to keep the sun from cooking the 817 if it happens to be a sunny day. So it looks like that when it's all mounted in. And to swap bands, basically, I disconnect the IF, the 10 meg reference, and the power connectors, pull that unit out, slide another one in, and I'm on a different band. Quick and simple. Now then, a bit more gain required, get a bigger dish. So everything now sits in a 60 centimeter dish with Cassegrain feed. And that works a lot better. Gives me a fair amount of gain. I made up these feed horns to go on the front ends of the waveguides. Machined them out of some bits of aluminium I had kicking around. 3D printer. Dave KK does that. He's got all the maths worked out and the spreadsheet and everything. So you just basically he's got to the point where he can just say, these are the parameters of the dish. This is the frequency I wanted to work on. Go and come back the next day and it's printed.
What's it covered with though?
That one has got copper foil stuck, as adhesive copper foil stuck all over the front of it. But there's also you can just use nickel spray paint. That works just as well. And that is the whole get up at the Chill site, which I had it up there once upon a time. It's a bit of a slope up there, though. Everything didn't really want to sit too well, but I think we were up there for a contest. I can't remember now. Yeah. Anyway, 122/134 gigs. There's a German company, Silicon Radar, recently acquired by Indie Semiconductor, make a range of ICs that put all the hard stuff in a chip. The TRA 120.002 covers 119.3 to 125.8 gigs. So 122 gig allocation is smack in the middle of that. The 045 chip covers 113.9 to about 134. It's spec'd to 134, but that's where our allocation starts. Fortunately, most of them will work above 134. It's just a case of how far. Problem for the Europeans is their activity is all at 134.9. Don't ask me why. I'll settle for 134.1. Job done. They also make other chips for 2460, 120, and a 240 gig chip. They all require an external PLL chip plus some control circuitry. Dave 5KK has done all the hard work of designing and building these units using the ICs. He's done all the hardware side of the world. My contribution has been the software for the Arduino microprocessor that controls everything that goes on them. On receive, they use an IF radio on 144 megs, just like any other transverter, they down convert. For transmitting, they direct generate the output frequency. There's no up mixing or conversion or anything like that. So the only available modulation type is changing the frequency. That's all you can do. So that allows for CW. When you're in key up mode, you just shift the frequency half a meg away. When you key down, you just reprogram the PLL to put it where you're operating. These things always transmit. They're always radiating RF somewhere. FM, I feed audio into the 10 meg reference. Job done. FM's it. Digital modes, specifically JT4 is built into the thing. I've got the Arduino module. You feed audio from your laptop running WSJT into the Arduino. It works out what frequency is coming in and reprograms the PLL on the fly to shift the frequencies to match. The receiver provides, this is the chip, provides IQ outputs, so theoretically a 3 dB improvement, but in practice, the IQ is a bit flaky, not that good. That's the block diagram of the 045 chip. So you've got a VCO here. There we go. There's the VCO. There's a divide by 64. So coming out here is 1.9 gigs or thereabouts. which is what the external PLL works on. There's 2 control voltage inputs to the VCO. There's a couple of amplifiers there. There's the 90 degrees, which is a bit iffy, sort of 90 degrees. And there's IQ mixers down here, amplifier on the receive side. The antennas are in the chip. There are 2 dipole antennas inside chip. So basically you put the chip where you want the RF to be working from. The controlling the thing, Arduino tablet. So you just plug that into the USB connection on the Arduino chip, and the tablet powers the whole module, right? So the 5 volts coming out of that will run the whole thing. So you just need a tablet or a phone, whatever. And that bit of that app on there is a serial I/O arrangement. So you can program up buttons, all these buttons down here. You can pre-program to do certain things. And that's what works the whole thing. That's what the front of one of them looks like. There's a chip sits at the front there. That's my patented attenuator. A bit of 2 before. You just put it in front to reduce the signal when you're testing. Arduino board mounted on top, and that's the whole arrangement with the 122 gig bits sat in that little same dish cradle arrangement. 5817 there. That's that's a couple of batteries to run it. 10 meg reference hanging off the side, and that was in Tasmania. I decided we better set a 122 gig state record for VK7, so me and Dave took our gear over there and did just that. As I said, you can do FM. My 10 meg reference is that little OCXO there, and these things have an input pin where you can adjust the tuning of the thing by varying the voltage. I just add some audio onto that, and I got a little audio amplifier kit from JCar, and this is microphone output there, designed to drive a loudspeaker. So that sits in this box here. I've got a jack where I can plug the Yaesu mic in, and there's a cable just plugs in there, and it takes the power from this thing to run all that lot. And FM's this. It needs, surprisingly, to get, it's a 10 meg thing going up to 122 gigs. You're multiplying 12,000 times. Yeah, it still needs, on the control pin of the OCXO, somewhere around 1.5 to 2 volts of audio to get sufficient deviation. This is just for narrowband FM, so it is, yeah. Anyway, coming up to the current year, photo on the left was me participating in a BK3 microwave activity day. We're doing a caravan trip over that way, and I thought, I'll chuck all the gear in. They're having an activity day. So, yeah, there's quite a few guys come out. And the photo on the right was back in April, just gone. That's at Rapid Bay Beach. Day 5KK was up on the beach, just near the proof range up at Port Wakefield. And we were doing some surface evaporation ducting tests. So you're about 140 odd Ks apart, basically, at sea level. And we did this once before in 2018. And we made successful contacts on 10, 24, and 47 gigs doing that. This time, we only managed 10 and 24, nothing on 47 gigs at all. So it does depend a lot on the conditions on the day. 10 gigs is a no-brainer. You get 5, 9 plus full scale on the S meter. You can move the antenna left, right, and the signal does not disappear. It's huge. And it doesn't seem to vary a bit. I think it's better when it's windier, which seems a bit counterintuitive, because you would think, any sort of ducting effect to be totally destroyed if it was very windy, but no. That's about 25 dB gain on that panel. So, yeah, so I'm trying to think what that would be now, probably 3 or 4 degrees, at the 3 dB point. But I could sit there and swing that thing backwards and forwards and not lose the signal, Anyway, almost at the end. Very recently acquired, some SG Lab transverters. The one on the upper right is for 2.4, lower right, this one's for me, and the one in the middle, 1296. 1296 one, I've had for a long time. I got that in 2017. But the other two, we turned up about a month. So, I'm going to put them and those boards I've showed earlier for 5 things all in one box. I'm going to make up another all in one box, like that sort of thing. But this time with 10 gigs in it as well. And that 2.4 gig one up there can actually do 2.3 gigs. Just find anybody else that's got 2.3 gigs that can work with it. And that's about it. So that wallpaper there is some of the distance records I've set over the years at various points.